basic idea of this study was to compare the relative efficiencies of driving transportation vehicles, small, light vehicles for personal use, with biomass, looking at two different pathways. One pathway involves converting the biomass into ethanol and using internal combustion engines in the vehicles. The other pathway involves converting the biomass into electricity in a traditional combustion-based power plant, using that electricity to charge the batteries for battery-powered vehicles. What we found was that if your goal is to produce the most vehicle miles per acre of land, you do significantly better with existing available technologies in the battery electric pathway than you do in the ethanol pathway. There are a couple of things that are involved in the difference in efficiency. The first is that internal combustion engines are not very efficient. The basic reason for this is that in an internal combustion engine, you're trying to extract all the energy from the combustion process in a tiny fraction of a second before those hot gases have to get pushed out of the combustion chamber. In a power plant, you can optimize the combustion process to extract every last bit of heat from the combustion and, to the extent possible, convert that into electricity. The other thing that's important to remember is that the process of producing ethanol from biomass requires some energy inputs, and only some of the biomass is compounds that result in ethanol. As a consequence, the amount of plant energy that's eventually captured in ethanol is only a small fraction, a little less than half. If you burn the plants, you basically get all of the plant energy in heat. The data were surprisingly easily available. Basically, we looked up vehicle efficiencies that are published by the Environmental Protection Agency, and we looked at the ethanol and power plant efficiencies that are also available through major energy analysis organizations. The ones we used were captured in a life cycle analysis model developed by the Energy and Resources Group at the University of California, Berkeley. I think the thing that's interesting about this study is that it's a relatively obvious question once you ask it, but I think that nobody had really asked it before. In general, the kinds of motivations that have driven people to think about developing ethanol as a vehicle fuel have been somewhat different than the kinds that have been motivating people to think about battery electric vehicles. Where they overlap is in the area of maximizing efficiency and minimizing adverse impacts on climate. Since this is the primary area that we're interested in, it seemed very natural to ask the question about whether we would be better off thinking about investments in ethanol-based transportation systems or electricity-based transportation systems. One might say, well, aren't we looking at different time periods when we look at those two sorts of approaches? Because, ethanol is already blended into gasoline, and we know that there are many countries that run their transportation systems half or more on ethanol, and battery vehicles are just beginning to penetrate in the market. And while that's true, we are seeing big strides in the range and the manufacturing cost of electric vehicles. And it's also important to note that there are still important technology hurdles that need to be overcome in producing ethanol the most efficient way with a process that's called cellulosic ethanol. We're really seeing large-scale ethanol production from corn grain or from sugarcane, which is not as efficient as the ethanol production process would ultimately have to be in order to be widely deployed. So I think the bottom line is that with both of these technologies, we're looking at significant steps that need to be covered between where we are now and where we would like to be to see truly wide-scale application.